Welcome everyone. This is the second quantum revolution for job seekers, and we are Qubo Consulting Corp, and we make quantum accessible. So my name is AJ Sikora. I'm the co-founder and chief learning officer of Qubo, and Dr. Katanya Kuntz is with me as well today, and she's the co-founder and chief executive officer. And we want to welcome all the students, the professors, all of the researchers, and everyone involved from Kwame Nkrumah University of Science and Technology. All right, so who we are. So once again, I'm AJ, and my background is in education as well as business. So I have a background working in various small businesses and understanding how they run and operate. I did a number of sales while I was younger, and then I actually went back to school, got my degree in education to become a teacher because I love the process of teaching and learning. And so throughout my career as a teacher, I really learned about how to break down dense, difficult, technical concepts to reach everyday people. So I had a number of students. I was a junior high teacher, and I would try to make math learning fun for them. And so I feel like if I can do that, then hopefully I can make quantum fun for you to learn as well. And Katanya, would you like to introduce yourself?
Sure. Hello, everyone. I'm Dr. Katanya Kuntz. I'm an experimental quantum physicist and, as AJ said, co-founder and CEO of Qubo. So my background is experimental physics and RF engineering, electrical engineering. So I bring in the technical expertise to our company. If any of you have really geeky questions, I'll unmute myself and try to answer. And yeah, it's just so wonderful that we could be a part of this. Thank you.
Excellent. Thank you, Katanya. Okay, so I just want to mention everybody is welcome here at Qubo. We really try to reach every learner. And so if there's anything that you don't understand, that's okay to ask questions. If you want, you can use the raise hand feature in Zoom, or you can type it in the chat. And keep an open mind. So if there's something that's kind of dense or tricky to understand, it's okay if you don't fully understand it. Just try to figure out, what is it that I do understand about that topic? What's the overall general understanding that I should take away from this? And so I'd like to pose a question to all of you. You don't have to answer this if you don't want, but if you want to type it in the chat, feel free. So what do you think you're going to learn about today? I'll give you maybe a minute or 30 seconds to reflect on that. And like I said, if you want to write it in the chat, you can write.
Even with online talks, we try to create an online community. And so we encourage this back and forth.
Katanya, I have a question. If I move my Zoom window up here, can you still see the whole slide?
Yeah, I don't see any difference on our side.
Okay.
Yeah.
I'm just going to keep it up here. Excellent. So let's move along. So first of all, what this presentation is not. Let me get my tin hat out here. Oh, there's a chat comment.
There's a chat comment. Go back. Keep your
Excellent.
tin hat on.
Excellent. I'm going to keep the hat on. So the impact of quantum technology in job acquisition. Excellent. Yes, Akawa, we are going to talk about how to look for jobs in the quantum industry. So, but what this presentation is not, it's not robot butlers, doom and gloom, and tin hats. Nope, I don't even need my tin hat today because those are not required. We're going to talk about just the real quantum here today. Not all the, dishwasher tabs and Marvel movies and things like that that have the word quantum in them. So here's a look at what we'll talk about today. Yes, excellent, Moses. This is going to be fun. So section 1, we'll look at the economic impacts of quantum technologies. There's the quantum threat, quantum solutions, and we'll also talk about the quantum workforce and quantum jobs. And then in section two, we'll look at the quantum global market, where we talk about global investment in quantum. So that's really interesting to see which countries are investing in quantum and how much. And then we'll talk about some of the major players on the global stage. So who are the big companies that are looking into quantum right now? All right. So some of the areas of quantum technologies that are being commercialized are here. So computing. Everybody, whenever I talk about quantum to the average person, they immediately assume quantum computing. So within quantum computing, we have some interesting, exciting things coming out like optimizations. So optimization could be something like improving the route delivery so that you have to drive less, use less drivers. You could save money on gas and resources and maybe on trucks. And then there's quantum simulation. And what quantum simulation is simulating a natural environment using a quantum system. And so with that, that could have huge implications in R&D, such as like new materials discovery or new drug discovery. And then we have quantum communication, so transmitting information in a quantum state from one party to another. And there's a protocol within the quantum communication that is theoretically 100% secure. And then we have quantum sensing. So using quantum properties or quantum materials to sense things. And they're supposed to be more precise and more sensitive than regular sensors or classical sensors. And then I always like to mention quantum random number generators. So in cybersecurity and in a number of applications, we need random numbers. We need randomness. And so if we use an algorithm to develop a random number, then that algorithm could be detected and it could be a flaw in the system. So with quantum random number generators, they are purely random. And there are a number of different platforms that are coming out with that as well. Okay, so the second quantum revolution for job seekers. Let's take a look at the economic impacts of quantum technologies. So before I get into this, I just want to pose a question, and I want you to start thinking about this. You don't have to type this or anything, but what is your ideal quantum job? And as we go throughout, maybe this will change, and maybe this course will help you figure that out too. Okay, so let's take a look at the quantum threat. So if quantum computers are expected to be exponentially more powerful than classical computers, then that is a threat that it could break current encryption standards that we use today. This threat is expected to happen sometime in the next maybe 5 to 15 years. There's no set timeline on this. It depends on how quickly that technology can be developed. Now, to kind of further compound this issue, it's expected that foreign adversaries could be stealing encrypted data today and storing it in its encrypted state. They can't access the information yet, but they're holding on to it until they have a quantum computer that is sufficiently powerful so that it can break that encryption that we have. So that could be an issue for people who have data that has a long lifespan, such as, healthcare data or maybe government data or communications that have taken place that you wouldn't want, foreign adversaries to get a hold of. As well, I want to talk about the hype. There are a number of organizations that really try to use fear to motivate people to start investigating quantum. And so I'm always just a little bit leery of people like that. So just make sure that, if you are investigating post-quantum cryptography or another solution, that, it's the best solution for your organization or for your school. Okay, so there are some quantum solutions, and then we're going to talk about industry impacts. So First of all, quantum matter behaves differently than things do in the classical world. It has special properties that exist on that scale that can be utilized to create new and improved technologies. And here are some of the exciting things that quantum technology could do. So, just to let you know about the timeline, some of these aren't going to be commercially available for a really long time. Some of them might be a medium term, some of them might be in the near term, and some things like quantum sensors might be available now. Okay, so let's look at the data security industry. So this industry could be vulnerable to a quantum threat, which has large implications for some organizations. Like I mentioned, if governments have sensitive data, that would have a long lifespan. They wouldn't want that data to get into the wrong hands, even if the data is 5 or 10 years old. The issue for larger organizations that typically have these long lifespans of data is that the transition time to get a new system in place could take a really long time. It might take them, a few years, maybe 5 years or so, to figure out which new solution they would like to implement. And then it might take another few years to get the funding to implement that solution. And then the actual transition of implementing that new system might take another few years. So it's good to be aware of the transition time for something like that. So, yes, we have this quantum threat, but there are also quantum solutions. And so one of those solutions is called post-quantum cryptography. And what that is using more robust algorithms that are designed to be resilient against a classical threat, such as the ones that we see today with AI, as well as a future quantum threat. And the good thing about post-quantum cryptography is last summer, the US government announced 4 candidates that they recommend using for post-quantum cryptography. So we have a good idea of where to start at least. And then the other solution, this is that 100% secure, at least in theory, is quantum key distribution. And that is a physical protocol that cannot be hacked due to some of the special properties of quantum physics. The next industry is manufacturing. So we could use quantum systems to simulate a natural environment to develop new materials. Perhaps you want a new material that has a specific compression strength or exhibits a certain heat capacity or something like that. So we could actually simulate it on a quantum system and then test it in the real world and hopefully eliminate a large amount of the research and development that would go into that. As well, we could see optimizations improve efficiencies in things like production, logistics, and supply chain. In the healthcare industry, we could see a lot of quantum applications. So once again, the simulation we could use for materials discovery could also apply to drug discovery. And so we could develop new drugs that are more efficient, maybe more targeted to the individual. We could see things like enhanced diagnostics by using quantum sensors. We could have improved medicine. Maybe sometime in the future, we could see virtual doctors and individualized treatment plans. And of course, data security is an issue for the healthcare industry because healthcare data is very sensitive and doesn't really have an expiry date. Then there's the travel, transportation, and logistics industry. And we could see optimizations improve things like fuel efficiency and route optimization. Maybe we would see quantum sensors being utilized to improve safety and navigation. It's possible that quantum sensors could help detect things that we can't detect right now, like if, flying in a cloud, for instance. Perhaps a quantum sensor could help you detect where objects are within that cloud. and the finance industry. So there are direct investment opportunities into quantum companies. Right now, I know there are a number that are traded on the stock market as well. Utilizing quantum tech in the finance industry, we could do financial modeling and portfolio optimization. And as well, all the transactions that take place on the internet involving money require an authentication process, and that could potentially be improved with quantum tech as well. Okay, so hype. I want to mention the hype because it's important to take kind of a middle ground here with the quantum industry. So, quantum is not magical. Beware of anybody that says that, quantum's gonna solve all the world's problems, eliminate cancer, and everybody will be happy. So, it has the potential to solve some really important problems for us, but we don't know what problems it will be able to solve until we have all of these functional technologies available. And the timeline. So the general consensus from experts that I've seen is roughly in about 5 to 15 years is when we'll see a fault-tolerant quantum computer come online. And it's important to know that some tech is commercially available now, and there is a huge potential to disrupt pretty much every industry. It's hard to think of an industry that won't be touched by quantum tech. And the time to prepare is now. Okay, so let's talk a little bit about the quantum workforce. So there are master's and PhD programs available for people who want to get involved in the quantum industry. The quantum industry needs skilled workers, but it also needs people to upskill from other industries to enter the workforce. So here's a little bit of information about Canada. This is where we're located, by the way. So the quantum workforce. So there's a massive demand for skilled workers. It's estimated that by 2045, the Canadian quantum industry will account for more than 200,000 jobs and be worth $139 billion. The Canadian government has invested more than $1 billion in the quantum industry since 2012. And we have something called a national quantum strategy, where the government has committed $360 million into these three pillars. Research, which is for basic and applied research to produce new solutions and innovations. Talent, they've committed 45 million to develop and retain quantum talent and also to attract experts to Canada. So if you are an expert in quantum, the Canadian government is interested in bringing talented workers to Canada. And there's also money committed to the commercialization pillar, and that's to turn research into products and services that will benefit Canadians and the world. And I love that the Canadian government says that they want to benefit not just Canadians, but the world. So I think that's really cool, and I'm proud to be part of that. So um, we'll need to fill skilled workers to enter the industry, and there are PhD and master's programs, as I mentioned. But maybe post-secondary institutions will start to offer certificates soon. So I know Katanya and I have spoken to a number of post-secondary institutions, like, colleges or polytechnics, and they seem very interested in offering quantum certification. And demand for technical skilled workers to work on quantum technologies will be very important for them to transition the non-technical workers as well, because we need both technical and non-technical workers. That's one thing that people don't always think of. They think of the PhDs, the doctors, but they don't necessarily think of the HR managers or the project managers that need to know, a little bit about quantum. They don't need to be a quantum physicist, but they need to know a bit about quantum to join the industry. Okay, so quantum jobs. I have a small little task for you. So hopefully, if you have a pen and a piece of paper in front of you, or if you can write it down, or maybe take notes on your computer, please do. So the goal is to find a fulfilling, challenging career that pays you what you're worth. Okay, so the assignment here, I want you to list all the tasks or activities that you have enjoyed about your past and present employment. Okay, so think about your interests. What things have you enjoyed doing? These could be things like interacting with customers, designing logos, planning events. Maybe it's customer service. There's no right or wrong answer here. I just want you to list things that you have enjoyed about working with either a past employer or a current employer. So now we're going to look at the skills. So what skills do you have? What are you good at? These can also be qualities about you. So things like communication, graphic design, organization. Maybe you're a good negotiator. I want you to list the things that you are good at or skills that you have developed. All right, so now what I want you to do is I want you to compare the two lists and think about what you like to do and what you're good at. And the intersection of these two lists is where you're going to find the optimal job satisfaction. That's how you find that engaging, enriching, challenging career that you enjoy and love. And now I'd like to ask a question. Can you think of a fulfilling career or a fulfilling role that you'd like to explore? And I have some tips here. So if you create a Venn diagram, that's what this, oops, sorry, when I touch the mouse, sometimes it skips. But this diagram right here, this is called a Venn diagram. It's where you have two circles and they overlap. So this circle is the interests that you have. This circle is the skills that you have. And then where they overlap here, that's where you find job satisfaction. And it's good to consider all of your options when you're looking for a new job. Okay, so let's look at some of the roles that will be needed to fill in the quantum industry. First of all, we have the technical roles. So we have quantum hardware or a software engineer, maybe an algorithm developer, quantum systems architect, maybe a quantum security specialist, quantum applications specialist, quantum metrologist. So that's like the sensing. And then policy analysts. Maybe we'll need a quantum communications specialist. We also need data scientists, database engineers, cryogenic engineers, and circuit designers. We know of a cryogenic company here in Alberta, in our province, where they actually look for technical people who know how to weld, and then they train them on quantum technologies, and they help build their cryogenic dilution refrigerators. Okay, and then now we have non-technical roles as well. And this kind of, sometimes people forget about this, but we also need all the regular business people that go into every other industry to join the quantum industry as well. So maybe a business development manager. We need marketing and communications people, sales people, human resource managers, project managers. We'll also need product managers, customer service. There will be a need for legal assistants and business analysts, as well as people who know how operations work. So take a look at this list. There's a number of roles here that don't involve technical quantum training. So I want to point to you, there's this opportunity that MyTax is actually one of our partner organizations. We develop and deliver workshops for them regularly. And the workshops are intended to draw attention to their internship opportunities. And so internships are a great opportunity for people to explore new roles and new industries. And it's kind of like trying on a hat. Like, does it fit? Do you like it? Is it comfortable? Is it something that you could see yourself doing in the long run? And they just kind of let you dip your feet in and try it out. So um, MyTax has over 20 years experience in the innovation ecosystem, and they help college, undergraduate, graduate students, and postdoctoral fellows access funding and source research placements in their chosen discipline and gain invaluable hands-on experience by applying their expertise to real-world projects with leaders in industry and not-for-profit organizations. And they can help you with funding, research experience, connecting with collaborators, and applying your expertise to real-world projects. So, MyTax has a website here. I'm just going to point it out down here at the bottom. Katanya, would you mind writing this in the chat? It's just www.mytax.ca. And so they help you find funding, and they will help you find a placement as well. So they have some different programs available. They have, I don't know how many, maybe like 15 or so, but they have global programs, which I wanted to point out because not all of them are global. Some of them are just for Canadian citizens, but they do have global research partnerships as well. And so there's the possibility of sending a student from Africa to Canada to join a research group and do a project here. And there's also opportunities for students from Canada to go to Africa. So it depends on what you're interested in. And you can check out their programs if you go to mytax.ca. I think it's called programs. I want to say it would be this tab right here that you would click on programs. So once again, some of the benefits is to progress your research, explore innovative projects. You can gain experience, get paid, and I always think this is the most important part is to see if you actually like that type of work. As I mentioned, it's like trying on a hat. So I really think that, these short-term employment contracts are a great way for you to dip your toes in and see what you like. And then it also helps you with that Venn diagram. So you can maybe develop new skills that you have, and you might find out more interests that you didn't know you had. So it'll help you with your job hunt. Okay, so let's look at some like actual quantum jobs here. So if you're interested in finding a quantum job, there are a number of ways that you can search for them on the internet, and I'm going to share them with you here. So we're looking at a company here called D-Wave, and D-Wave is a quantum computing company. They offer quantum optimizations, and I think they're the only quantum computing company that is commercially deployable. And what that means, I'm not 100% sure. I heard the CEO say it on CNN last week, so but he made that claim, so that's pretty interesting. And so they have a ton of jobs available on their website. So in business services, they need a purchasing coordinator. In research and development, they need a senior algorithm researcher. They need a senior high-speed, low-noise design engineer and an experimental physicist in coherence measurement. That's just some of the jobs that are available. And if you want to see more of them, I can't highlight this because it's a PDF. Katanya, would you mind typing this job link into the chat?
Sure. Yeah, and I got the other one in there too.
Excellent. Thank you so much.
No
And
worries.
so some examples of jobs, they have purchasing coordinator, senior algorithm researcher, software developer in test, senior manager product marketing. They need a senior solution architect in optimization. And I always find this interesting when they say open expression of interest, that is phenomenal because you can pick what your ideal job is and then pitch it to them. And then if they think that's a great idea, then perfect, you've got your dream job. Many companies that are in this new emerging industry have open expressions of interest because they're interested in finding the right people for their team more than they are finding a specific role to join. And some other companies that you can look up, you see these down here. And once again, I should mention I will share these slides with all of those who attended today. I'll share them with Dr. Henry Martin, and then he can send them to the people who attended. But here are some companies that you could look up for jobs as well. SB Quantum, Photonic, Xanadu, Anion. These are all Canadian companies. One Qubit is also Canadian. Then we have IBM, Google, Honeywell, um, Pascal, Nord Quantique, Keysight Technologies, Cubic. These are just some of the quantum companies that you could look at. Okay, but maybe you don't want to go company by company looking for a specific job. Maybe you want to look at a job post board. And so job post boards are phenomenal for finding quantum jobs. Um, I think that looking at a consortium website like QEDC is probably the most efficient way to search for job roles. So we have examples of available jobs on this website. Quantum research scientist with AWS, integrated photonics scientist with light integration technologies, uh, high-powered computing dev hybrid for Xanadu, technical writer for Q Control, quantum technical sales engineer at Pascal, laser engineer at Atom Computing. So you can see they've got some real technical, some really interesting job roles here. And there are other consortia that you can look at as well. So there's Quantum Industry Canada. To be honest, we're a part of Quantum Industry Canada. I love them, but they don't always have a ton of jobs like QEDC. QEDC has like pages and pages of jobs. Um, and then there's the Chicago Quantum Exchange. That's a very big, quantum network, and so they should have a ton of jobs posted there. And there's a new one called Elevate Quantum, and I believe that one's in the US as well. All right, so here's a look at Quantum Industry Canada's membership, just to show you how many people are involved in the quantum industry. So here are all the full members, and so here you can see Qubo Consulting Corp. We're very proud to have our logo up here with all these big fancy companies and everything. Um, and then they have associate members as well. And you can see some big names there: Honeywell, IonQ, Keysight, Pascal, and then as well some affiliate members down here. And I'm going to give you some advice as well about finding quantum jobs. So look for creative ways to find job and internship opportunities. And I always like to tell people about this. So look at recent investments. So companies that make a big raise in the VC world when they're doing venture capital and they raise and then they say, "Hey, we've just secured $5 million to grow our business." Those are the companies that are going to be hiring. They need people to fill roles. They're raising money to grow the business, and you grow the business with people. And so I always think when you see an announcement like that come out and you're a job seeker, check out that website. And it might not even be updated yet. Maybe you want to send them an email and say, "Hey, congratulations on this raise. Sounds like your company is growing. Would you be interested in a person with my skill set? And here it is. And here's why you would want me." You can also try to spot trends and be proactive. I like this 3 words: network, network, network. That means talk to people, meet people, ask for introductions to other people, and just try to expand your network. And the bigger your network is, and the more robust it is, the easier it will be for you to find that ideal job. And then, as I mentioned, you could also research quantum consortia websites to find out which ones keep current job postings and then search for an applicable job. And the social media platform that we use as Qubo is LinkedIn. So you could create a LinkedIn account and start making posts and comments and try to grow your network that way. And here's a really important note at the bottom here. The key to job satisfaction is finding the intersection of your skills and what you're interested in. And it's all about you. It's your life, and you might as well create the one that you want. Okay, so take action. Remember, you don't need a PhD in quantum physics to join the industry. You can do it with a different role, a non-technical role as well. But it is important to develop a general understanding of the implications of quantum technologies and start building quantum literacy now. Educating yourself will ease the transition and make you more employable. And you can search for quantum training programs to help you get there. All right. And so quantum training, we do have quantum workshops, as I mentioned, with MyTax. So if you join their Edge platform, I'm not sure how you join, but I think if you're interested in their internships, you can probably register for their website. And we have one more quantum training workshop with MyTax this year, and it's next week on, Katanya, do you have the date?
The
Is it
17th, December 17th,
December 17th? Yes, in
Tuesday.
Canada. Yes.
Yeah.
It might be a little bit late in Ghana. I'm not sure.
In
So,
Ghana, it'll be
anyway.
in the evening. It'll be if it's 4:30, is it 4:30 there or 3:30 there right now? 3:30 in the afternoon. I think it'll be 6:30 in the evening in Ghana. Start. Yeah.
Okay. Yeah. And then we're hoping to launch our own e-learning courses online on our website in winter 2025. And you can check out our website to see when that gets updated. But we also have a ton of free content. We have lots of videos. We have lots of links to things on our website, like any talk that we give that's recorded and put up online. We have that on our website as well. We have a couple of blogs as well. Okay, so now let's look at the economic impacts, or sorry, that's the end of the economic impacts. But I have a reflection question for you again. So, what is your ideal quantum job, and how can you get from here to there? And you don't have to write this down, and you don't have to put it in the chat or anything. But I would like to get you to think about that. And I see a question from Moses in the chat says, will it be virtual as well? Yes, our MyTax workshops, they are all virtual. And so you can access them as long as you have an internet connection.
And we've had international students join, so it's very possible that the MyTax Edge system might be available to you.
Hmm. Yeah. Okay, so now we have a little knowledge check. We like to have fun testing you on your knowledge to make sure that you're listening and you're understanding what we're saying. So, number one, when do experts think current encryption standards will be broken by a quantum computer? Within the next 3 years, in 2032, in roughly 5 to 15 years, or yesterday? So when will a quantum computer break current encryption standards? When do you think? And you don't have to write this in the chat or anything. If you have a piece of paper, you can write it down so you can track it, and then we'll go through the answers right away. Oh, some people are writing in the chat. Excellent.
I
Yes,
love
you're both
that.
right. C, in roughly 5 to 15 years. There's no set date. We're not sure. It depends on how quick we can overcome these technological bottlenecks. And it also depends on the level of investment interest from various governments and from private sources. Number two, why would a business or government need to worry about a quantum threat even before a quantum computer is capable of breaking encryption standards? A, two words, Donald Trump. B, because dishwashers already have quantum and they could revolt against humanity. C, because threat actors could be stealing encrypted data and storing it until they are able to break the encryption with a quantum computer. Or D, because quantum computers cannot break RSA encryption now. I don't need to worry yet.
I love how there's an A in there. Yeah,
Yes,
Donald Trump would be a threat, eh?
we're all worried about that threat, I think.
I know, I sent
Yeah.
the laughy face reactions.
All right, there we go. Yes, C is the correct answer. But yes, we're all worried about the Donald Trump threat as well. Don't worry. He called us the 51st state the other day, I heard.
Oh my goodness.
Yeah. Number three, what kinds of workers will the quantum industry need in order to grow and reach its full potential? A, technical roles such as software engineers, algorithm developers, security specialists, and policy analysts. B, non-technical roles such as sales, project managers, human resource managers, Marcom, and legal experts. Sorry, Marcom is marketing and communications. And C, Ant-Man to shrink down to make sure all the qubits are working. D, is it all the above? Or E, is it A and B? Excellent. Oh yeah, we definitely need Ant-Man to shrink down. Ooh, excellent. I think everybody's paying attention today.
Well done, everyone.
Awesome. It's both A and B. Yes.
I think they're liking your
And
jokes there.
I'm glad you enjoy my sense of humor. Awesome. Okay, number four, job satisfaction comes from aligning which of these features, and you can select more than one on this one. So job satisfaction comes from A, things you enjoy, B, tasks you can get done quickly, C, doing nothing and making bank, or D, things you are good at. So you can pick more than one on this one. This one's, I know, a little bit different. So based on my talk, when I said job satisfaction comes from the alignment of these things. Excellent.
Very
A,
nice.
A, B, D. Excellent. All the above. Yeah. It'd be nice to do nothing and make bank. Excellent. So, yes, so the optimal job satisfaction comes from doing things that you enjoy and things that you are good at. Excellent. That's where the optimal job satisfaction is here. Okay, internships. Internships offer interns which of the following opportunities? And you can select all that apply. A, gain real world experience. B, funding for your project, for example, your salary. C, hot air balloon rides. Or D, to determine if you like that type of work. And you can select whichever ones you think apply. So, what are internships good for? Which of the following opportunities? Excellent. Yes. All right. So yeah, unfortunately, no hot air balloon rides. But hey, if you make bank doing nothing very quickly and you get funding for your project, then you could always just go on a hot air balloon ride. Okay. So now let's take a look at the quantum global market. And I have a question for you. There's no right or wrong answer, but which country do you think invests the most in quantum technologies? Asari says, yes, please, to the hot air balloon ride. Funny story. I've been to Africa before, and I was in the Masai Mara in Kenya, and I was supposed to go on a hot air balloon ride, but I can't remember. It was the weather wasn't right that day, or something was wrong, and so we ended up not being able to go. But I would like to go on a hot air balloon ride sometime. Okay, excellent. So now looks like lots of people answering. USA, Canada, Germany, China, Japan, China, Canada, China, Switzerland, China, Canada. Excellent. Wow. It sounds like you guys might already know a little bit about this area. So let's take a look at the global market. So taking a look at some investment numbers, these are from 2022, 2023, and some from 2024. So in 2022, global investment reached $2.35 billion. It dipped a little bit last year to $1.2 billion. That was sort of a global trend in investment. And so in other industries, they experienced the same effect. So I'm not too concerned about that. And this year has had lots of investment already. And as I mentioned, Canada's national quantum strategy is $360 million that they've committed over 7 years. And by 2045, I think I mentioned this before, but the quantum industry will account for more than 200,000 jobs and be worth more than $139 billion. And in November 2023, that's about a year ago, Photonic Inc. raised $100 million. Here are some other raises. So Quantinuum in the US, they raised $300 million. And the interesting thing about that is it put their valuation at $5 billion. dollars. So that means that their market cap, the overall value of their company is $5 billion dollars, and they raised 300 million. So that is quite a bit of funding. Pascal, which is based in France, they raised 100 million euros, and that put them at a valuation of just over 400 million euros. Photonic Inc., as I mentioned, raised 100 million, and Sandbox AQ, they raised the most. That was in 2023 with $500 million. They're a Google spinoff, so that's how they have like that kind of power and connections to raise $500 million, um, which is a lot of money. But hey, if you're looking for a quantum job, these companies looks like they have a ton of money. They're probably growing. So you could always pitch your ideal job to them. Okay. Global quantum investment in raw dollars. So this was in 2022. So China had invested $15 billion. This is cumulative investment. So up everything up until 2022. USA, 3 billion. Germany was third at 2.7 billion. France invested 1.8 billion. The UK, 1.2 billion. Look at Canada's number six. This is back a few years ago. We've dropped a little bit since then, but just under $1 billion there. India was at 800 million, and the Netherlands 684 million, and then Israel at 400 million. And let's look at those numbers as a percentage of gross domestic product, because I feel like it's important to look at that because that factors in the size of the economy and how much of that economy they're investing into quantum tech. So China is still the leader here. Israel jumps up to number two. The Netherlands is number three. Germany, I believe they stayed at number four. Maybe they dropped from third to fourth. And then Canada actually jumped up a spot to number five. USA drops all the way to nine here. But once again, this is a couple of years old. I'm going to show you a map here that has the most current data that we have. So this map is put out by our friends at Curica. They also do quantum training as well. And we love this map that they put out. And so you can take a look at some of these different countries here. We don't see Ghana mentioned, but we can see that South Africa has invested $3 million into quantum tech, which is very interesting and very good to see. Um, Here are the top five as of 2024. The top five countries are number one, still China. The USA has invested a bit more now, so it looks like they've put in about two, or at least they've committed about $2 billion more. The UK is there at 4.3 billion. Germany has 3.3 billion invested, and France is 2.2. And all of these figures are in US dollars. Okay, so some more trends. So recently, Quantum raised close to $1 billion Australian, giving it a valuation of 3.1 billion. They raised roughly 630 million US. And then there's Quantination Ventures. They closed a 70 million euro round towards its goal of 200 million euros, and they support and invest in quantum startups. And Quantum Circuits raised $26.5 million in May, and Alice and Bob received 16.5 million euros in innovation grants in March. Okay, so here's just a list of some of the major players in the quantum industry. So we've got Google, IBM, Microsoft, Amazon, Alibaba, Intel, NVIDIA. Like some of these major players in the tech industry are really investing in quantum. Okay, so now another reflection question. Which country do you think will develop the first fault-tolerant quantum computer? UK. Nice. China. Yep. Well, based on numbers, right? Yep. China. Germany. Excellent. I could see that. The German are so organized, right? Very punctual and on time. They'd make sure that the qubits are working. They wouldn't need Ant-Man to shrink down to fix them. China. Excellent.
Totally.
Yeah. You know, like I know Australia isn't on the map really for investment. Like they're on the map, but they're not investing huge. But like with Psi Quantum's investment, that could be a game changer. You don't really know. Yeah, China, USA, excellent. And there's no right or wrong answer. I don't know. We'll find out in a few years, I guess, maybe in 5 to 15 years. Okay, so knowledge check. Number one, there are already quantum unicorns. And unicorn is a term that we use in business for companies that are worth more than $1 billion. Uni means one, right? So unicorn, it's like a mythical creature. It's like a, you know. Anyways, so there are already quantum unicorns worth more than $1 billion. Is that true or false? Or are unicorns not real? No, that's not a thing. There's no such thing. And if you want to type your answer in the chat, you can. True, true, true. Excellent. Yes, I see all the truths coming through. That is correct. And here are some examples. Sandbox AQ, Quantinuum, Psi Quantum, and etc. Man, I can't believe that. Sandbox AQ raised $500 million. Like they're a startup. How did they get $500 million? Crazy. Anyways, number two, Google, Microsoft, Amazon, and Nvidia, the tech giants, are all involved in quantum. True or false? A, true. Yeah, true. Excellent. It is true. Yes. So it's good to know. Like these are the tech giants and they're all investing in quantum. So it's not like it's a, mythical industry or something. This is a real industry. There's real money going into it. And these major players are paying close attention to it. Okay. So last question for you today. What is one new thing that you learned today? You can type it if you want. If you want to unmute and say it, we'd love to hear your voice. It's okay if you're shy. If you want to type, and I know sometimes these responses take a minute, so I don't mind waiting.
We need some Jeopardy music in the background. No. Oh, there they go. There they go.
See, we knew you were typing. We just wanted to give you time. Excellent. So, preparedness for a quantum job. Excellent. Yes, that's what I was hoping to impart today. Quantum science isn't going to go to an end. Yes, exactly. No, quantum science, it's a real industry and it's just becoming commercialized now. China is the leading investor of quantum tech. Yes. Quantum is about to take over the world in the tech world. So, yeah, I mean, quantum tech, I don't know if it's necessarily take over, but it's definitely going to impact and influence every industry. And one thing I should mention, I know a lot of people think that quantum is going to replace our computers, our communications, etc. But quantum is more likely to be integrated with other technologies. It's not going to replace them, it's going to enhance them. And let's see what else. The current capabilities of quantum technology in security. Excellent. To get a job, interest and skills. Oops, sorry, it keeps moving. Interest and skills must go hand in hand. Yes, Akwasi, thank you so much. So, like my personal journey, I saw a career counselor at one point in my life before I got my Bachelor of Education. And that was the main takeaway that I learned from that was if you want job satisfaction, if you're looking to be happy in the long run, then you need to consider yourself. What do you enjoy doing and what are you good at doing? And that's the optimal job satisfaction. That's how you're going to find fulfillment and happiness in your career. Africa needs to start investing in quantum technology. Yeah, it is important for everyone to get invested in stuff. And you know what? And our goal is to help grow the global quantum ecosystem. So we're really happy to deliver this free talk to Knust. and your students and faculty. So thrilled that you could join us today. We love helping to grow the global quantum ecosystem. Thanks for attending our session. Please. Oh, sorry, that was Katanya.
Yeah, that's right. That's a new thing I learned now.
Yeah, and there are more avenues for studying quantum more than ever before. Yes, exactly. And we're helping with that. We're going to try to get some courses filmed and up on our website and available to be viewed. And preparing for a quantum job and investing in quantum tech. Excellent. Okay, so let me go back to my slides here. So thank you so much for participating. Please feel free to reach out and connect with us on LinkedIn. If you enjoyed this session and you want to post about it, like tag me and we'll repost, we'll amplify it and everything like that. And we'd love to answer any questions that anybody has. If you have technical questions, Katanya's here to answer them. If you have non-technical questions, then I can answer them. And thank you so much for your time today and inviting us. Thank you so much to Dr. Henry Martin for inviting us. This has been amazing.
Yeah, so happy this could work out. Thank you. Great job, AJ. Well done. Yeah, any questions, raise your hand, type in the chat. We're happy to stay on for a few more minutes if you'd like. I think people are very appreciative of your presentation, AJ, there. I'll just start answering what I think the question is. If there's any applications of quantum technologies in carbon capture and emissions reductions and green energy applications, and the short answer is yes. So there's optimization algorithms that can help with those types of things. There's better gas sensors using quantum sensing technology to improve the emissions detection. There's also quantum sensors to help with, say you want to improve your solar farm or your wind farm. And so it's very difficult to monitor solar and wind in certain conditions. And so you can improve the efficiencies of your wind farm if you have a better sensor. So there's quantum sensors for better wind speed. Yeah, so we actually recently gave a presentation to a network in Canada that was focused on agriculture and manufacturing. So yes, there's definitely a lot of applications of green in the greenhouse gases and battery, also designing better batteries. So battery technology, materials design, all of these types of applications. And there might be more on our website coming soon because it sounds like this is an interesting topic for a lot of people.
Yeah. Are there any other questions? Happy to answer any. If there are no further questions, then thank you all very much for your time. Thank you to the Kwame Nkrumah University of Science and Technology for having us here. Thank you once again to Dr. Henry Martin for inviting us and connecting with us and making this possible. And we're so thrilled that we had so many people interested in learning about the second quantum revolution for job seekers. And we hope that this was valuable for you and helps you in your journey as well. So thank you all very much and have a wonderful day.
Thank you for participating.
Thank you. And thank you for all your questions. Thank you for answering all of our quiz questions and everything. And
And
have a
thank you for
wonderful.
enjoying our humor.
Yes. Thank you for not taking us too seriously.
This is our balance, Sometimes quantum technologies can be very overwhelming and confronting. And so this is our way to balance that.